Hello and welcome to Stories of Science. Here, we look back on humanity's long journey to understand the world. The questions, the failures, and the breakthroughs that slowly changed how we see the universe and ourselves. We tell science as stories. Poincaré, the genius who bridged science and ethics. Did you know that Poincaré was doing addition at the age of 3 and solving complex math problems in his head by the age of 4? His childhood genius grew in a home where education was taken very seriously, almost too seriously. In 1854, the beautiful city of Nice in France witnessed the birth of a future mathematical giant. Poincaré's father, Dr. Léon Poincaré, was a respected doctor, and his mother came from a family that valued strict discipline, creating the perfect academic environment for him. In those days, Poincaré's upbringing was what we'd call the old-school family model, heavy on self-discipline and academic rigor, with sky-high expectations from his parents. Honestly, if I were asked to solve a math problem at the age of 3, I'd probably burst out laughing. But not Poincaré. His talent made his parents incredibly proud. However, the career path his father envisioned for him created a huge internal conflict. His father wanted him to follow in his footsteps and become a doctor, but Poincaré's interests lay elsewhere. "My father wanted me to become a doctor," Poincaré once humorously said. "But my interest in medicine is like your interest in overtime zero." You see, the dry, formulaic nature of medicine didn't sit well with him. Poincaré's passion was in exploring the mysteries of the world, not in fixing human bodies. From an early age, Poincaré displayed an incredible mathematical talent. By 3, he was doing simple addition, and by 4, he was already solving complex math problems in his head, leaving adults in the dust. This talent left his parents in awe and made them realize that Poincaré's future was not going to be in the operating room, but rather in the classroom with mathematical formulas. The academic atmosphere at home was strict, with his mother particularly emphasizing the importance of education, leading by example and fostering Poincaré's self-discipline. While his father hoped he would pursue a career in medicine, he never forced it upon him. Poincaré's father's expectations remained a strong influence on him, pushing him forward with that parental pressure that many of us are familiar with. Imagine this: a 4-year-old boy, tapping away at an abacus, while 2 stern parents stand by, waiting for him to solve a seemingly complex math problem. What a picture! But Poincaré didn't back down. In fact, he became more focused. He began exploring even more complex mathematical problems, attempting to crack puzzles that left adults scratching their heads. But here's the kicker: Poincaré wasn't just a math genius, he was also a master of humor in the academic world. His math was so precise it left people stunned, but his jokes were just as precise, leaving everyone in stitches. He had a unique sense of humor, one that was as sharp as his mathematical formulas, always lightening the mood at the perfect moment. It's been said that Poincaré's humor was ubiquitous. He was rigorous in his academic work but always found ways to bring joy to his friends. As he once put it, a real mathematician should have a sense of humor about life. He often combined serious mathematical theories with lighthearted humor, explaining complex concepts with simple, witty remarks. For example, Poincaré would lighten tense academic discussions with math-related jokes, making dry research feel a bit lighter. His humor wasn't just a personality trait, it became part of his charm in the academic world. Poincaré had the unique ability to diffuse the tension in academic debates, bringing a little levity to the conversation. As many scholars have said, Poincaré wasn't just a great mathematician, he was a humor master who made the academic world a bit more fun. Now, you might think that Göttingen University was just any university, right? Wrong. It was the cradle of mathematics. It's here that Poincaré met the giant David Hilbert, becoming a rising star in the academic world. This university wasn't just any top-tier institution, it was a mathematical powerhouse. Imagine Poincaré's life in Göttingen as a young man entering the mathematics superstar club, where he could sit down with Hilbert, Bohr, and others to discuss the mysteries of math. Göttingen gave Poincaré the ideal academic environment where his mathematical brilliance was allowed to truly flourish, especially through his collaboration with Hilbert, which was electric. The intellectual sparks between these two math giants pushed Poincaré further on his path. Picture this: Poincaré sitting in a café in Göttingen with Hilbert, Bohr, and others, delving into the mysteries of math. At that time, he might not have fully realized he was in one of the most pivotal periods of math history, a storm of knowledge, with each drop being a groundbreaking theory. In Göttingen, Poincaré wasn't just engaging in academic exchanges, he was also participating in significant mathematical research, touching areas far beyond pure mathematics, including physics and astronomy. His thought process and academic pursuits helped him win widespread acclaim. It was here that Poincaré's fame began to spread, and a new star in the mathematics world was born. Poincaré's mathematical talent as a young man was nothing short of divine. Within just a few years, he became one of Europe's youngest math prodigies. His name began circulating in academic circles, and his accomplishments went far beyond the realm of typical mathematicians. Not only did he shine in pure mathematics, but he also made outstanding contributions to fields like physics and astronomy. This young genius was an all-rounder in the academic world. His mathematical abilities were so impressive that even the big shots of the time had to take notice. In his pursuit of mathematical excellence, Poincaré wasn't just a pure theorist, he was also an academic adventurer, crossing boundaries from number theory to geometry, from calculus to astrophysics. Poincaré didn't just make waves in mathematics, he also made groundbreaking strides in the intersection of math and physics. His work on the Poincaré conjecture and Poincaré group became milestones in math history. His contributions weren't just about formulas and theorems, they laid the groundwork for the integration of modern math and physics. Under Poincaré's influence, many future scholars adopted his interdisciplinary research methods, and even after his death, the academic world remained deeply influenced by his work. Poincaré went from a rising star to a leader in the mathematical world, earning international acclaim. In 1929, Poincaré's academic career took a turn. When he moved to the United States to join the Institute for Advanced Study at Princeton, he didn't put down his mathematician hat. Instead, he began exploring entirely new academic territories. But wait, did you think this was his retirement? Far from it. This turn wasn't a pause, it marked an even more intense academic pursuit. Princeton University, one of the most influential academic institutions in the world at the time, gave Poincaré a new platform. Here, he didn't just immerse himself in the sea of mathematics, he worked alongside physicists like Einstein and Bohr, crossing disciplinary boundaries. This was like a dream come true, except this dream was set in Princeton, a place full of infinite possibilities. Poincaré's academic transformation at Princeton marked a key point in his life. His thinking expanded beyond the narrow confines of mathematics to broader scientific fields. During this time, Poincaré contributed greatly to interdisciplinary scientific research, and his academic influence reached its peak. Poincaré's impact on interdisciplinary research didn't just push mathematics forward, it also influenced innovative thinking in physics. While at Princeton, he became a titan in the math world, injecting fresh ideas into the ongoing scientific revolution in physics. Princeton's academic environment was crucial to Poincaré's success, and it was here that his influence in the academic world reached its peak. Poincaré's academic transformation at Princeton was a turning point in his life. His thinking expanded from narrow mathematical frameworks to encompass broader scientific fields. For some time after, Poincaré continued to contribute to interdisciplinary research, leaving his academic footprint in multiple fields and influencing countless future scientists. You ever hear of the Poincaré conjecture? Sounds like it could be the name of a fancy restaurant, right? But trust me, it's far more than just a name. It's a bombshell in the history of mathematics, one that didn't get fully solved until 2003. Can you imagine? From the time Poincaré proposed it, it took an entire century to crack. It's like buying an incredibly expensive GPS, only for it to tell you where you're going, 100 years later. Poincaré's contribution to topology essentially redefined the map of mathematics. What used to be simple geometry got transformed into a whole new system thanks to his higher-level math. The Poincaré conjecture was about the structure of 3D space, but solving it had implications that reached all across mathematics. It wasn't until 2003 that Russian mathematician Perelman used modern mathematical tools to prove this conjecture, and that was a massive leap for mathematics, leaving a lasting shockwave. When it comes to topology, Poincaré essentially installed a GPS in the world of mathematics. But instead of guiding you to a destination, he rearranged the entire geometry of the world. The catch: the final answer didn't come until 2003. It's like giving a lost friend a navigation system, and they only figure it out a century later. Imagine the magnitude of Poincaré's contributions to math. He practically swept through the entire fields of geometry and topology. But Poincaré didn't just stop there. His second major contribution? Dynamic systems and chaos theory. Yes, he laid the foundation for what would become the study of chaos theory with his Poincare-Lyapunov theorem, which became the bedrock for future work in dynamical systems. You might be thinking, what's dynamic systems and chaos theory? Did these mathematicians use these to predict the weather? Well, in a way, yes. Poincaré, by studying chaotic systems, foresaw the rise of chaos theory. He was like the mathematician version of a prophet. He noticed that systems that seemed completely random actually had patterns that could be predicted. The only problem was, these patterns were so complex that even Poincaré couldn't fully understand them. If he were around today, he'd probably get a kick out of how even modern-day weather forecasting still grapples with these complex mathematical models. Chaos theory is all about understanding systems that look random at first glance. But Poincaré managed to frame these chaotic systems in a way that allowed scientists to begin analyzing them. Think of it like opening the door to the hidden secrets behind chaos, all thanks to Poincaré's mathematical framework. Imagine Poincaré unlocking the key to understanding chaos through math. And today, even weather forecasts continue to be challenged by these complex mathematical theories. Poincaré's insight made tackling the scientific mysteries of chaos a little more manageable. As for the weather, well, that might still need a sequel from Poincaré. Now, let's talk about Poincaré's contributions outside of mathematics, specifically in physics. While Einstein is known as the father of relativity, Poincaré actually laid the theoretical groundwork for it long before Einstein came on the scene. You see, physicists and mathematicians are often collaborative creatures, and Poincaré was a pioneer in that cross-disciplinary cooperation. Poincaré's work in physics, particularly his research into electromagnetic fields and the symmetry of physics, provided new perspectives on these concepts. He gave mathematical support to Einstein's theory of relativity. Although Einstein's work ultimately completed the theory, Poincaré's mathematical contributions were absolutely essential. His analysis of physical symmetry and the mathematical properties of electromagnetic fields became the foundation of relativity. Poincaré's relationship with Einstein could be described as peers with shared vision. When Einstein was developing relativity, Poincaré's mathematical methods were a crucial tool. Without Poincaré, Einstein might have had fewer insights, and his theory may not have come together so smoothly. You could say Poincaré's mathematics acted as an accelerator for Einstein's theory, propelling it forward. Look at it this way: Poincaré didn't directly create relativity, but he provided the most essential theoretical support. If he had left a note saying, "I didn't invent relativity, but I did the groundwork for mechanics and electromagnetic fields," he'd have been right. After all, the hardest part isn't inventing a new theory, it's laying down the foundation for one. And Poincaré? He was the unsung hero behind the scenes. Now, have you ever wondered how to make smart decisions in the world of competition and cooperation? Well, Poincaré's game theory is your answer. But don't be fooled, this isn't just a game of chess. This is the key to unraveling complex social behavior. Poincaré's collaboration with economist Morgenstern led to the book Theory of Games and Economic Behavior, which laid the groundwork for the birth of game theory. Imagine Poincaré taking complex social interactions, especially those involving competition and cooperation, and translating them into mathematical formulas. It's like speaking life philosophy in math language. The term zero-sum game quickly became a hallmark concept in the academic world. Simply put, a zero-sum game means that in a competition, one person's loss is another's gain. It's like playing chess: if you win, your opponent loses. Not too complicated, right? Winner takes all, loser gets nothing. Poincaré and Morgenstern's work laid the formal foundation for game theory. You can imagine these two mathematicians using their mathematical magic to transform complex social behavior into a clear mathematical model. It was this thorough analysis of complexity that gave game theory its real-world applications. Did you know that game theory isn't just taught in math classrooms? It's become an invisible weapon in business, international relations, and military strategy. Poincaré's theories didn't stay in the ivory tower, they've made a huge impact in real-life scenarios across the globe. Today, companies use game theory to analyze market competition, even in price wars. Picture this: two big companies battling for market share, fighting a price war. Behind the scenes, game theory is at work, with strategies designed to outlast the other. It's not random behavior, it's a finely calculated game strategy. And here's the real kicker: game theory's influence has expanded beyond business and into international politics and military strategy. Think about the Cold War, when superpowers were locked in a nuclear arms race. It wasn't just about military power, it was a game theory exercise. Every strategic decision was calculated to maximize gain without actually firing a shot. International negotiations and diplomatic games are also driven by game theory. You might think diplomats are just good with words, but in reality, they spend their days carefully designing strategies to maximize their nation's gain on the international stage. Just like Poincaré and Morgenstern predicted, these so-called negotiations are really mathematical strategic games at play. Imagine you're the leader of a nation, facing a powerful opponent. You need more than just economic power, you also need the wisdom of game theory to predict your opponent's reactions and take the most beneficial actions for your country. That's the magic of game theory. It helps you navigate complex interpersonal and international relations, giving you the strategy to win the game. Poincaré wasn't just a mathematician, he was a cross-disciplinary innovator. To him, math wasn't just for calculations and formulas, it was a tool to solve societal problems. Poincaré combined math with social science, and that's where the magic happened. Game theory's emergence showed that math isn't just about solving equations and drawing graphs. It's about understanding and solving the conflicts and cooperations in real life. From family squabbles to international warfare, Poincaré's mathematical thinking opened up new perspectives. Have you ever thought about how math could play a role in solving societal problems? For example, how can governments balance competing interests when making policy decisions? Or how can they predict different groups' reactions and make the most optimal decisions? Poincaré's cross-disciplinary thinking turned math into the master key for society's complex issues. Poincaré's contributions go beyond math. His interdisciplinary ideas revolutionized economics, psychology, politics, and even military strategy. Today, from Silicon Valley to international diplomatic tables, game theory offers new perspectives and solutions for decision makers. And the best part? Poincaré's academic legacy is still alive today, influencing global scientific research, particularly when it comes to understanding human behavior and solving complex societal problems. If Poincaré were alive today, he'd be amazed at how his theories continue to shape every aspect of our lives. Imagine this: you're a mathematician, suddenly tasked with calculating the time and intensity of a nuclear explosion. Sounds like something out of a sci-fi movie, right? But this is exactly the kind of project Poincaré, the math giant, contributed to. Yes, Poincaré, the same legend who laid the foundation for modern math, helped explode the world of nuclear science with his math formulas. In the heart of the Manhattan Project, Poincaré's mathematical genius was put to extraordinary use. His precise mathematical simulations helped nuclear scientists predict the timing and intensity of nuclear reactions. These weren't just math problems, they were determining how science would shape the future of warfare. Without Poincaré's contribution, the development of nuclear weapons might have been delayed by years. Poincaré's mathematical models acted like a silent powerhouse, laying the groundwork for nuclear explosion calculations. His thinking broke through the limits of technological development, turning complex nuclear reactions into controllable, calculable processes. Behind all this? A professor who once stood in front of a classroom, teaching math. Poincaré's mathematical models were like a silent, invisible machine working behind the scenes, laying the foundation for nuclear explosion calculations. His thinking pushed the limits of technology, making those complex nuclear reactions not only controllable but computable. And the best part? All of this came from a professor teaching math in a classroom. This mathematical explosion of his undoubtedly changed the course of the world. You may never have considered it, but when we talk about the catastrophic consequences of nuclear weapons today, Poincaré's mathematical simulations played a pivotal role. But Poincaré wasn't just a calm, calculated mathematician. He understood that his work could lead the world to disaster. His involvement in the Manhattan Project wasn't just about showcasing his math skills, it was about the difficult choice between science and morality. Imagine a mathematician who knows his work could cause immense suffering. How does he reconcile his contribution to such a deadly cause? Though Poincaré understood the horrific consequences of nuclear weapons, he still chose to participate. You could say he was serving science, or you could say he made a compromise in the war between science and ethics. Years later, Poincaré deeply reflected on the consequences of nuclear science, warning all scientists, the double-edged sword of technology cannot be ignored. Poincaré's message was clear: science is more than just calculations and experiments. Scientists are not just discoverers, they are bearers of responsibility. From Poincaré, we see the immense potential of science and the moral dilemmas it can bring. Yes, science advances the world, but it can also change the course of history. In this process, responsibility and consequences are just as important. Imagine Poincaré, knowing his formulas were used to destroy entire cities, what would he have thought? This kind of deep self-reflection and awareness made him a true scholar, one with a high sense of social responsibility. This tug-of-war between ethics and science may never fully disappear. Today's tech giants are still making similar choices. Poincaré's reflection remains a reminder for every modern tech worker to consider their role in shaping the future. You might be wondering, what's Poincaré's place in modern mathematics? He was the game-changer, but the impact he left is far greater than you might think. His influence spans mathematics, physics, computer science, and even future technologies. Poincaré's legacy is still alive and well today, transcending time and disciplines, even inspiring advancements in quantum computing and computer science. He was more than just a genius who flipped the mathematical world upside down. His interdisciplinary legacy broke down the barriers between fields, making those boundaries seem smaller and smaller. His mathematical ideas weren't just formulas, they shaped how we understand, design, and run modern technology. Did you know? His ideas have sprouted like seeds, still growing in the soil of today's computing and tech industries. Poincaré didn't just rock the world of mathematics, he's also played a huge role in advancing the teaching and industry of modern computing. When you try writing a program or use code to make your dreams come true, you might not think about it, but Poincaré's mathematical framework helped guide us in thinking about data, computation, and information. Quantum computing may have surpassed Poincaré's time, but his thinking still holds a place in that space. Today, quantum computing and computer science are deeply influenced by Poincaré's spirit. But Poincaré's influence didn't just stop at computers and quantum fields. His work has had a profound impact on the development of supercomputers and AI technology. When we talk today about how AI simulates human thinking or makes decisions based on data analysis, we're continuing Poincaré's work using math to understand the complex world, even simulating complex thought processes. Look at how Poincaré's interdisciplinary thinking showed us how to build bridges across different fields. Today's scientists are still drawing from his theories, especially in areas where multiple disciplines merge. Poincaré's contributions have become the cornerstone for many of today's cutting-edge research. From a modern academic perspective, Poincaré is undoubtedly a giant. His interdisciplinary vision continues to influence scholars across mathematics, physics, and even social sciences. Scientific progress isn't just linear growth, it's a process of constantly crossing boundaries, sparking new ideas. Poincaré's multifaceted contributions were a driving force behind this. His interdisciplinary thinking shows us that science isn't just about breakthroughs in one field, it's the result of multiple fields blending and advancing together. You might not realize it, but many of the technological innovations you see today can trace their roots back to Poincaré's ideas at pivotal moments. Let's imagine today's computer science, quantum technology, and even supercomputers pushing the limits of science. These technologies weren't just born from constant trial and error in labs, they have theoretical foundations that often required Poincaré-style interdisciplinary thinking to pave the way. Looking at these world-shaking innovations, isn't Poincaré the one who opened all the doors to science? His academic influence still quietly spreads through every research project today. So, when you use modern technology for high-efficiency computing, research artificial intelligence, or listen to cutting-edge quantum computing lectures, you're unknowingly connecting to Poincaré's spirit. Those complex formulas and profound theories are easier to understand today, thanks to Poincaré's wisdom halo that has illuminated each new generation. What he gave us wasn't just the answers in math, it was a whole new way to think about the world. Poincaré, the forward-thinking mathematical giant of his time, continues to shine brightly in every technological innovation and academic exploration today. You might think mathematicians are cold, calculating, formula machines, focused only on computations. But Poincaré, he wasn't like that at all. Did you know? Not only was Poincaré a math genius, but he might have been one of the most humorous mathematicians in academia. Yes, you heard that right, Poincaré was full of humor. It's been said that Poincaré's math wasn't the only thing precise, his jokes were spot on too. At academic conferences, Poincaré would often break the tension with a well-timed joke, lightening the mood to something almost like a family gathering. Despite being a math giant, in life, he was a humor master. This humor didn't just win the admiration of Einstein and Bohr, it earned him deep respect from his academic peers. Imagine discussing the mysteries of the universe with these physics giants, then suddenly getting hit with a joke. Wouldn't it make the conversation a lot more relaxed? Poincaré's humor wasn't confined to academia. In his personal life, he was just as good at diffusing awkward moments at family gatherings. He might have been an academic superstar traveling the world, but he kept a deep, loving connection with his wife, balancing his career with family life. No matter how busy he was, he always made time for his family, finding warmth in the little moments. When it comes to Poincaré's place in history, it's incredibly interesting. Today in the world of science, Poincaré is like an invisible giant. Whether it's quantum computing, artificial intelligence, or supercomputer research, Poincaré's shadow is everywhere. Think about it, without Poincaré, would we have so many interdisciplinary innovations today? Without him, our phones, supercomputers, and even the game theory analysis methods in modern economics wouldn't be nearly as cool. His innovative spirit transcended math, affecting physics, computer science, and even sociology. Poincaré's thinking shattered the boundaries of disciplines. His contributions weren't just limited to math, they deeply influenced every facet of modern technology. Every time you turn on your computer, make a complex mathematical calculation, or engage in an advanced physics experiment, Poincaré's interdisciplinary thinking is there. The birth of modern computer science, the formulation of quantum mechanics, and the application of game theory, they all owe a debt to Poincaré's insights. Poincaré didn't just reshape mathematics, he advanced the cross-disciplinary development of science. His academic methods and innovative ideas continue to influence scientific research worldwide. Modern scholars, especially those in interdisciplinary fields, often look to Poincaré as a role model, pushing boundaries and fostering new knowledge. The connection between modern technology and Poincaré's work grows tighter every day. Today, the computational frameworks behind supercomputers, the intelligence behind AI, are all deeply influenced by Poincaré's thinking. You may not realize it, but Poincaré's early research on complex systems laid the foundation for what we now understand about AI and machine learning. Every innovation you create bears the marks of his intellectual sparks. So, when we talk about quantum computing, supercomputers, and artificial intelligence today, these cutting-edge technologies are really just the continuation of Poincaré's mathematical ideas. His cross-disciplinary thinking opened up a new world for technological development. Every time you use technology, whether you realize it or not, you're benefiting from Poincaré's gifts. Even if his name isn't as widely recognized as Einstein's, his impact on the progress of science is just as significant. Every computer you use quietly carries Poincaré's wisdom behind it. Today, looking back at Poincaré's contributions, we see not just his influence on mathematics, but also his revolutionary approach to interdisciplinary thinking. Poincaré didn't just settle for making his mark in one field, he was like a master chef, blending different academic ingredients into brilliant dishes. Whether it was math, physics, or computer science, Poincaré's wisdom has lit up the night sky of human civilization. So you see, Poincaré wasn't just a math genius, he was the invisible hand behind modern technology. Today's academic world is still drawing from his way of thinking. Imagine, could you, like Poincaré, break out of the boundaries of your field and explore the unknown with relentless curiosity, pushing the progress of science? Poincaré's story continues to inspire everyone passionate about scientific exploration. Like him, constantly breaking boundaries and challenging the unknown, could that make you the force that changes the world in your own field? The people who change the world usually just think one step deeper. If this story made you see things differently, hit like, subscribe, and save it. See you in the next story.